Okay, hello students. We have a uh, control system module 2 block diagram and signal flow graph. In that, I'm going to give a first lecture on this. Myself, Prakya D, working as assistant professor in the Department of Electrical and Electronics Engineering. So the first concept in this is the block diagrams. So this picture will shows you how exactly the block diagram has to be represented. So the block diagram is a consisting of a single block or a combination of block that are used to represent the control system in pictorial form. So this is how the representation we are going to do. The basic elements of block diagrams, we have a basic elements, that is a blocks, summing point, and as well as takeoff point, and input and output representations. So these are all the basic elements which is needed for a block diagram. So let us discuss each and every individual elements. First one, we are going to take it as block. The transfer function of a component is represented by a block. So the block here, the indication is G of S. The block has a single input and single output. So the input is X of S and the output is Y of S. And the following figure shows the block having input X of S and output Y of S and the transfer function G of S. So the transfer function G of S is equal to output by input, that is Y of S by X of S. So Y of S is equal to G of S into X of S. Next we have a summing point. The summing point is represented with a circle having cross mark inside it. So you can see here the cross mark inside it with a circle. So that we call it as a summing point. It has two or more inputs and single output. See here, two or more input it is going, and there is only one output. You are going to get it out of that summing point. So that it produces the algebraic sum of the input. So how many input is there? We need to add that, and the output will consisting of all the addition of the inputs. So that is Y is equal to sum of A and B, because A and B are the input signal here, A plus B. Y has a difference of A and B, that is A minus B. If you have any this one second representation, you have a signal and you have a B signal with negative sign, so that is A minus B. So it also perform the summation or subtraction or combination of summation and subtraction of the inputs based on the priorities of the input polarities of the input. Let us see these three operations one by one. So we discuss all these things now. Then we have a basic connections for blocks. There are three basic types of connection between two blocks. That is series connection. Series connection is also called as cascade connections. In the following figure, two block having a transfer functions G1 of S and G2 of S. Okay, so here we have G1 of S and as well as G2 of S. Input is X of S and output is Y of S. The output of first block is Z of S and input of second block is Z of S. So by this, the combinations we are going to discuss. What is Y of S? Y of S is equal to G2 of S into Z of S. What is exactly the Z of S? That is input into block. So G1 of S into X of S, that is Z of S. So what is total Y of S now? This is G2 of S into G1 of S into X of S. So totally we have G1 of S, G2 of S into X of S. So Y is the final expression is G1 of S, G2 of S into X of S. Compare the equation with standard form of the output equation, that is Y of S is equal to G of S into X of S, where G of S is equal to G1 of S into G2 of S. So series combination, what is that series combination? If two blocks are in series, you can make it a single block, that is G1 of S into G2 of S. Here you will be having a two blocks are in series and we make that into a single block. So input is same and output is same. So that means we can represent the series connection of two blocks with a single block. The transfer function of this single block is the product of transfer function of those two blocks. Okay, as I told earlier, it's a product of two blocks which is connected in series. That will make you a single block. So that is the series connection, and we have a parallel connection. So the parallel connection, you have G1 of S block and G2 of S block, and you have an input X of S and you have an output Y of S. Each block output is Y1 of S and G2 of S output is Y2 of S. So from this representation, we can easily tell that Y of S is equal to Y1 of S plus Y2 of S. So what is y1 of s? Y1 of s is nothing but x of s into g1 of s. Y2 of s is nothing but x of s into g2 of s. So y of s is equal to addition of these two, that is g1 of s into x of s plus g2 of s into x of s. So if you take x of s common, g1 of s plus g2 of s. So output by input, if you do that, you are going to get G1 of S plus G2 of S. So wherever you got the parallel block, you need to make that a single block. Okay, this means we can conclude that if you have a parallel connections of two blocks with a single block, to make it a single block, the transfer function of these single block is the sum of the transfer function of those two blocks. Okay, we need to add these two blocks in order to make a single block. So the equivalent block diagram is as shown in the figure. So x1 of s is an input and y of s is an output, and g1 of s plus g2 of s, we need to add that. Then we have one more type of connections, you are going to get it in the block diagram, that is the feedback connection. So there are two types of feedbacks. One is positive feedback and negative feedback. So positive feedback, at the summing point you will be having a plus sign, and a negative feedback you will be having at the summing point the minus sign. So there are these figures shows negative feedback control system. Here two blocks having transfer function G of S and as well as H of S. So here, what is E of S? E of S is the X of S minus H of S into Y of S, because Y of S and H of S will multiply, and that is the minus sign it is having, and this is the X of S, the plus sign we will be having. So E of S, this is a summing point, these two has to be added. So you are going to get E of S is equal to X of S minus H of S into Y of S. So what is Y of S? The multiplication of these two, E of S into G of S. So Y of S is equal to, what is E of S? X of S minus H of S into Y of S. That has to be multiplied with G of S. So Y of S, we are going to take it as common, whatever the Y of S term we have. So Y of S is equal to 1 plus G of S into H of S. I taken this element in this side, and X of S into G of S you are going to get. So Y of S by X of S is equal to G of S divided by 1 plus G of S into H of S. So wherever you got the feedback network, you need to convert that feedback network into a single block with the help of this expression, that is Y of S divided by X of S, that is equal to G of S divided by 1 plus G of S into H of S. So next we will be moving on to the reduction of block diagram technique. So as I told, if you have any feedback network, you need to reduce to the single block with the help of this formula, that is G of S divided by 1 plus G of S into H of S. Wherever you have a negative feedback, you are going to get plus symbol here. Wherever you are going to get positive feedback, you are going to get negative symbol here. So like this, you need to convert any feedback system into a single block with the help of these two representation. Then we have a block diagram algebra for summing point. So we have a summing point here, and we have G of S here, and I'm going to move this summing point after the block. So we have a two possibility of moving the blocks, that is summing point, shifting a summing point after the block, and shifting a summing point before the block. So in the first representation, we are shifting this summing point after the block. Okay, so see here, you have a summing point here, and it is shifted over here. Okay, so the shifting has to be done with the help of this concept. That concept is whatever you are going to move, the same value you are going to get it in the G of S. Which block you are going to move the summing point after the block, that block value will becomes here at the feedback end. Okay, so we will discuss how exactly that is going to happen. That is the input of the block G of S. Okay, the input of the block G of S, that is R of S, is R of S plus X of S, because the X of S and as well as R of S, these two has to be added in order to get the G of S. Okay, so Y of S is equal to what? G of S into R of S plus X of S. So Y of S, finally we have G of S into R of S plus G of S into X of S. This is the output you are going to get it before shifting the any shifting point. So once you gone through the shifting of a summing point after the block, you are going to get like this. Okay, see here, if you go for this, R of S into G of S plus G of S into X of S is Y of S. See here, R of S into G of S plus G of S into X of S is Y of S. After shifting also, the output equation doesn't alter. Like that, you need to create that. So we need to introduce one G of S here in order to doesn't alter any of the output equation. So like this, you need to shift the summing point after the block and shifting the summing point before the block. You can see here the summing point is here. So Y of S is what? G of S into R of S plus X of S, that is Y of S. So if you shift this summing point before the block, what you are going to get? The same answer has to be get in order to get the output matching. Okay, so if you shift the summing point before the block, you are going to get like this. See here, R of S plus X of S, G of S, Y of S. So you are going to divide 1 by S, 1 by G of S if you shift before the block. Okay, so that is the consideration. See here, you are going to shifting the okay, next we will discuss how to create the block diagram algebra for takeoff points. So this is all for this lecture. Thank you.